So this is chapter 13-1 and it's titled Exploring Periodic Data. So for exploring periodic data, this is just some basic things that you should know. You should be able to determine whether each relation is a function. So number 1, you can see x and y, 2, 4, 1, 3, -3, -1, and 4 and 6. And you should be able to tell whether this relation is a function or not a function from previous chapters. Work on this on a piece of paper or really quickly on your head just to make sure that you know what this is and that you properly understand whether the relation is a function. So this is the answer for the first 4 problems. Going over number 1, 2, 4, 1, 3, -3, -1, 4, and 6 is a function because each element in the domain is paired with exactly one element in the range. So by the definition of a function, it's when the domain is paired with the range. So this is the answers for numbers 5 to 8, and you can see that number 5 is not a function because an element of the domain is paired with more than one element in the range. For 6, you can see the vertical line test, where the vertical line test did not apply to this because it's a circle and not a line. So here you can see some basic vocabulary. A periodic function is a repeating pattern of y values, which are outputs at regular intervals. A cycle is one complete pattern of the function, and a cycle can occur at any point on the graph of the function. And a period is the horizontal length of one cycle of the function, and the amplitude is half the distance between the minimum and maximum values of the function. So when you're exploring periodic data, you can analyze this periodic function or this cycle in 2 different ways, and then you can determine the period of the function. So you begin at any point on the graph and you trace one complete pattern. So you can see in the red line that's one cycle. So the beginning and ending of the x values of each of the cycle determines the period of the function. So each cycle is 7 units long and the period of the function is 7. So we're going to determine whether each function is or is not periodic, and then if it is, find the period. So the pattern of the y values in this one section repeats exactly in other sections, so the function is periodic. So to do this, you find points at the beginning and the end of one cycle, and you subtract the x values of the points 2 minus 0 is equal to 2. So the pattern of the graph repeats every 2 units, so the period is then 2. So we're going to find the amplitudes of the 2 functions in this additional example. So amplitude is equal to 1 over 2 maximum value minus minimum value using the definition of amplitude. And then that's equal to 1 over 2, which is 2 minus -2, which is substitution, which is then equal to 1 over 2 times 4, which is equal to 2. So you subtract within the parentheses and simplify, so the amplitude of the function is 2. So this is just continuing on in exploring periodic data. So this oscilloscope screen below shows the graph of the alternating current electricity supplied to homes in the United States. So you were going to find the period and the amplitude. So the 1 unit on the t-axis is equal to 1 divided by 360 s. So one cycle of the electric current occurs from 0s to 1 divided by 60s, and the maximum value of the function is 120 and the minimum is -120. So period is equal to 1 over 60 using the definition of it, and then that's equal to 1 over 60 when you simplify. Amplitude is then equal to 1 over 2, 120 minus -120, which is then equal to 1 over 2 times 240, and when you do that, it's simplifying to 120. So the period is 60 and the amplitude is 1 over half. And that concludes chapter 13-1, Exploring Periodic Data. If you didn't already, I highly recommend that you go back to the beginning of the video and write notes over this.